Have you ever wondered how things in the world are connected? If you do more of this one thing, what happens to that other thing? It's a question we ask all the time. And today, we're going to dive into two really powerful tools that help us find the answers: correlation and regression. They might sound a little technical, but trust me, they're all about uncovering the hidden patterns in the data all around us.
So, let's start with a question I think we can all relate to. We've all been there, right? It's late, you're staring at a book, and you're thinking, will one more hour actually make a difference on my exam? Well, this is the exact kind of mystery we're going to solve today. For our little investigation here, we're going to be tracking two key pieces of information. First, the hours studied. Let's just call that our X variable. And second, the final grade you get. We'll call that our Y variable. Simple enough. These two are going to be the stars of our show. Okay, first up, let's meet our relationship detector. This first tool is called correlation. Its whole job is to figure out if our two variables, our study time and our grades, are even connected in the first place. So what exactly is correlation analysis? Well, it's this really neat technique that takes all of our data, every single student's study hours and their final grades, and boils it all down to just one single number. And that one number tells us everything we need to know about how strong that connection is. It's basically a report card for the relationship. And that relationship score, statisticians like to call it R. It lives on a really simple scale, from -1 all the way up to +1. Think of it like a spectrum. A score of +1, that's a perfect positive connection, and -1, a perfect -1. So if we ran our numbers and found that R was close to +1, what would that mean? It means as our hours studied goes up, the final grade also tends to go up. It's what we call a direct relationship. More studying leads to better grades. Kind of makes sense, right? Now, on the flip side, a score near -1 tells us it's an inverse relationship. For instance, if we were looking at hours spent on video games versus grades, we might find that as one goes up, the other tends to go down. And what if the score is hovering around 0? Well, that just means there's no obvious straight-line pattern connecting them. The two things don't seem to move together in any predictable way. I mean, there's probably no connection between, say, how many dogs you own and what your final grade is. Okay, so we've got the extremes down, +1, -1, and 0. But what about all those numbers in between? How do we read a score of, say, 0.3 or 0.8? Let's break it down. This little table is a super handy guide. Generally speaking, this is how it works. Anything really close to 0 is considered pretty weak. As you start climbing, you get into fair, then moderate territory, but once you hit a score of 0.75 or higher, now you're looking at what's considered a strong relationship. So what does that look like in the real world? Well, a weak score means the connection is kinda loosey-goosey. The data points would be all over the place. But a strong score? That means the variables move together in a really tight, consistent pattern. That's a relationship you can actually rely on. And this brings us to a really important question. Let's imagine we've run the numbers and voila, we found a strong correlation between studying and grades. Awesome, we know they're connected. But so what? What can we actually do with that information? Well, this is where our second tool, regression, makes its grand entrance. If correlation is our relationship detector, then you can think of regression as our prediction machine. It takes that relationship we just found and turns it into a tool we can actually use to forecast the future. And really, the definition says it all. Regression lets one variable be predicted by the other. And that is the magic word here, predicted. We're not just measuring a relationship anymore. We're actively modeling it so we can make a forecast. So, why do we use regression? Two main reasons. First, to get a much deeper look at how, exactly, X influences Y. And second, and this is the really powerful part, to actually predict a specific outcome. We can now try to guess what your final grade will be based on how many hours you tell us you're going to study. So how does this prediction machine even work? Honestly, it's pretty straightforward. First, you just plot all your data points on a graph. Then some cool math happens to find the one single straight line that gets as close as possible to all those points. We call that the best fit line. And once you have that line, you can use it to make your predictions. And this right here, this is the engine inside our prediction machine. Now, don't let the letters scare you. It's just a simple recipe. X is your input, the hours you study, and Y hat is the output, your predicted grade. The A and B are just special numbers the analysis calculates that basically tell us where to start our line and how steep it should be. All right, we've met both of our tools. Now it's time to put them side by side, head to head, to make the difference crystal clear. This is it, the final showdown, correlation versus regression. Here it is, the whole thing in a nutshell. Correlation asks one question: how strong is the relationship? And its answer is that one single score. But regression asks a different question. What is the exact nature of that relationship? And its answer is a predictive formula, a tool. See? Two different tools for two very different jobs. And this quote really just hits the nail on the head. This is the main point. Regression does not tell you if the relationship is strong or weak. That's correlation's job. Regression's job is to build a model based on the relationship that correlation already found. They're a team. So let's wrap this up and bring it all back home. Back to our first question. Correlation came in and told us, hey, yes, there is a strong positive link between studying and grades. Then regression took that and gave us a specific formula to say, okay, great. Based on that strong link, if you study for 10 hours, we predict your grade is going to be an 88. But we have to end on a really important word of warning here. We found a link. We can even make predictions, but these tools don't tell us why that link exists, right? Could other things be involved? Maybe how much sleep a student got or their prior knowledge of the subject? This leads us to the most famous rule in all of statistics. Correlation does not equal causation. And figuring out that why, well, that's always the next great mystery to solve.